I'm going to talk about charge and electric force. In a lot of ways, charge and electric force are analogous to mass and gravitational forces. What do we know about gravitational forces? Well, two objects exert gravitational forces upon each other based on their masses. So you can have two objects separated in space, even in a vacuum, and somehow mysteriously these objects exert attractive forces on each other, right? And you probably know the equation to calculate the magnitude of the forces. They're opposite in direction relative to each other, and the magnitude is based on the amount of mass, right? Okay, so that's all well and good, but watch how similar this next statement is to the one that I just typed out. Two objects exert electrical forces upon each other based on their charges. So apparently, objects have this other property besides their mass. They have this other property that is called charge, and that leads to an additional type of force. Okay? The force is, we'll learn later that it's equal and opposite, just like gravity. Okay? But there are some differences. All right? So let me now talk about some more details regarding charge and electrical forces. So there are two types of charge. Okay? Positive and negative. We never said that there was two types of mass. We would measure mass and in kilograms, and there wasn't like different flavors of mass, okay? Different types of mass. However, that's not the case with charge. You can have different types. We will denote a quantity of the positive type by a positive number, and we will denote a quantity of the negative type by a negative number. Let's talk about the units. So mass is measured in kilograms. Charge is measured in units of coulombs. Amounts of charge are measured in units of coulombs. Okay, and that's abbreviated with a capital C. All right? Now, watch this. I'm continuing to give you other introductory facts about charge and electrical forces. Different types of charges attract each other. Similar types of charges repel each other. So if you have an object with a lot of positive charge and another object with a lot of negative charge, they will feel an attractive force, just like gravity, right? Gravity is always attractive. However, if they both have some amount of positive charge, or they both have some amount of negative charge, they will repel each other. Okay? So, unlike gravity, you can have repulsive forces. All right, now I would like to try to convince you that the study of charge and electrical forces is important, and then we're going to finish with a simulation and an experiment. Okay? So make a note of these introductory facts, and I'm going to give you, I'm going to make some other comments now. So, why is the study of charge and electrical force important? Okay, watch this. Almost all of chemistry is based on charge and electrical forces. So, you've heard about chemical reactions, right? If you take hydrogen and oxygen, they combine to make water. If you take an acid and a base, you might know that if you combine them, they neutralize each other, okay? And there's, of course, countless other chemical reactions we could talk about. Why do you think that chemicals do what they do? Why do you think they react the way that they do? Underneath it all, it has to do with the fact that chemicals have charge, and the charge exerts attractive and repulsive forces on each other, and that's what causes all of this drama, okay, all of this wonderful chemistry. So if you are at all interested in anything to do with chemistry, it will behoove you to know about charge and electrical forces. Okay? Now, biology is based on chemistry, so if you're interested in biology or medicine, it'll also behoove you to study charge and electrical forces. In fact, your own body runs, the operation of your body depends on charge and electrical forces. Did you ever wonder how your brain is able to tell your finger to move? Okay, you've got something called a nerve between your brain and your finger, and the communication down that nerve is based on electrical forces. Okay? Watch this. Much of modern society is based on charge and electrical forces. Do you think that the internet is a big part of our society? All the hardware of the internet is based on charge and electrical forces. Have you ever used an electric toothbrush? What about an electric car? Have you ever used a digital watch? Have you ever used a cell phone or any type of phone for that matter? Okay, or a computer? All of those objects, their operation depends on charge and electrical forces. So you cannot understand technology, okay, modern society without understanding charge and electrical forces. All right, now let's get some experience with this topic, shall we? Have you ever dragged your feet on a carpet, maybe intentionally or accidentally, and then you touch a doorknob and you get zapped? Or maybe you've gotten out of a car and you touch the metal of the outside and you get zapped? Okay? Why do you think that happens? Now, I'm not going to go into the details of why rubbing against the car seat or rubbing against your feet on carpet adds charge to your person, okay? But just accept that it does. And when you touch a doorknob or the metal on the outside of a car, what happens is that charge feels an electrical force, an attractive force, and so it leaves your body. And it's that charge leaving your body that you experience as that zap. Okay? If you want to investigate that further, I would invite you to play with the following simulation. Do an internet search for a simulation called PHET-John voltage. All right, and you can learn more details of how rubbing your foot on a carpet gives you charge, and then how it leaves when you touch a doorknob. Okay, or even just getting close to a doorknob can be adequate. All right? Now I'd like you to do the following experiment, and this will finish this video. We'll call this the clear tape experiment. All right, so stick 2 pieces of tape to the surface of a table or desk. Peel the 2 pieces of tape off of the surface and hold them close to each other. Do you notice the pieces of tape bending away from each other? All right, so let me describe what is going on here. All right, when you stick 2 pieces of clear tape to the surface of a desk or a table or something similar, and you peel it off, okay, you are literally ripping negative charge off that surface and adding that negative charge to those pieces of tape. All right, now let's think about what happens as you hold them, the 2 pieces of tape that are negatively charged close to each other. Okay, now they have the same type of charge. So doesn't that mean that the objects are going to exert repulsive forces on each other? So that's why you should see the pieces of tape bending away from each other. All right? Now, here's another experiment you could do in addition to that one. Try placing the pieces of tape close to other objects to see if they attract or repel other objects as well. So, what about your hair? If you place a piece of negatively charged tape close to your hair, you might have to look in the mirror to see the effect. Now, don't touch your hair with the sticky side. That won't be fun. But even just getting it close, does your hair move at all towards or away from the tape? What about water? Take a faucet and turn on the water just a little bit so you have a tiny little steady trickle. Okay? What happens if you bring a negatively charged piece of tape close to the trickle of water? Okay, try that. You'll see some interesting effects. All right? And then lastly, you can try this one. Stick 2 pieces of tape together and then peel them apart. Hold the 2 pieces close to each other and see if they bend towards each other. All right? Now, why would sticking the pieces to each other make the pieces of tape this time want to bend towards each other instead of away? Okay? Remember when I said that the tape literally rips negative charge off of another object, and like the surface of a desk or table? Well, when you have 2 pieces of tape, it turns out that yes, you are pulling charge off each other, okay? However, you will also be adding. One of them will be giving charge and one of them will be adding charge. So I don't want to go into the more detail than that, but the net effect will be that they will be oppositely charged. Okay? One piece of tape will be negatively charged. The other one will be positively charged. So we know that different types of charges attract. So that's why I'm predicting that you will see the two pieces of tape bend towards each other. Okay? So have some fun and make sure that you understand everything that's happening based on the introductory facts about charge and electrical force that I've just told you.